My internet is terrible.
Fear not, young friend.
Huh? No fear?
That is correct. You can make it better.
But how? My internet speed is terrible.
'Tisn't, friend. Only know these simple secrets to unlock new levels of speed, and your internet browsing will never again be slow.
What's up? Dr. Frank Pagoda, Dr. Anusha, and we are sick and tired of slow computers. We all have them in our lives, in school, at home, at the library. What is it that makes them slow though? You know, I can go and brag to my friends that I have the new Dell XPS with Windows 7 and 700 million gigabajillion bytes of RAM, but my computer still goes as slow as a turd on the internet. And why is this? Well, we're out to find out. What is it that significantly changes your internet speed? Is it that illegally downloaded movie that you're watching? Or that movie that you're illegally downloading right now? We're out to find out, and it'll be our mission to discover what it is that makes your computer a slow thing.
Oh, hello. Let me explain to you how the internet essentially works. Basically, bandwidth is the determining factor of your internet speed. All applications and processes utilize the internet to complete their designated goals. We believe that internet-active processes such as the downloading of a file and the ping process would significantly impact your internet speed, whereas processes that don't use the internet will not impact your speed whatsoever.
Cut my life into pieces. This is my last resort. Suffocation, no breathing.
I hope this works.
Let's hope so.
Alright, here we are, we're at speed test. What's up, world out there? Alright, so
Where are we going? Where are we going?
Alright, what about this arrow? Okay, so we got all these choices. I'm feeling Clifton.
Yep, Clifton.
Alright, so for those of you out there, this is our control, first test of of our big statistics experiment. Maybe it'll be fast, we don't know. Alright, here we are. Ping, 5 milliseconds. Whoa!
Oh my god.
Oh my
god.
whoa.
Look at that.
No way!
Jesus.
Whoa!
26.
What
25,
the heck?
20. Oh. There
Oh,
you go.
bro! No!
Impressive. Very impressive.
Oh my god! Oh, that is too crazy. Alright, upload speed is not part of this, but that's still pretty impressive there. But, 24. Oh boy. After some long, hard, arduous hours of speed testing, the learning team finally had a formidable collection of data. As you can see from the table currently displayed, the data spanned quite a large range, signified by the high standard deviation of 8.13. The learning team believes that this large range is due in part to the varying bandwidths and internet service providers of the different private and public locations that were utilized in the collection of the data. In addition, the team believes that this range should have no effect in the end calculations and analysis. This controlled condition data, which again involved a speed test performed while no other user-initiated programs were running, saw speeds ranging from 6 megabits per second to as high as 40.
After the control condition was completed, the learning team conducted several speed tests for each treatment. One while a large file was downloaded. Another with a media file playing in the background. An additional test with the ping command launched in the command prompt. One more test with an antivirus program running a virus scan. Another with the program rendering and converting a video file to a DVD format. And lastly, a test was conducted within a safe mode, the least processor active state for a Windows computer.
As they said in The Day After Tomorrow, we have mountains of data, but not nearly enough computer power to analyze it. Well, the learning team situation is slightly different because we do have enough computer power to analyze it. The team has selected to use a one-sample t-test to statistically analyze the data because we are dealing with data from a sample and values that are not from a population. Because really, who has enough time to measure all the computers in the world? We use this one-sample t-test, but with one provision. We did not use the actual data values. Rather, we used the changes in speed from the control condition to the treatment condition. This is the cornerstone of the matched pairs design that is used in this experiment.
As per requirements of the matched pairs design, the following tables display the changes in speed from the control condition to the treatment conditions for each subject in the experimental sample. The means displayed below literally show the average change that was caused by the treatment. However, the means alone do not determine whether there is significant evidence that the treatment increases or decreases internet speed.
Hello there. One important question to ask ourselves is how can we decide if the changes we have found are significant of a computer's reduced internet speeds? For the answer, we can turn to good old-fashioned analytical statistics.
The learning team's predictions involve whether or not certain treatments decrease speed. Therefore, since the data used in the t-test represent the changes in speed, the null hypothesis is that the mean is equal to 0, which indicates no change in speed for the treatment. Likewise, the alternative hypothesis is that the mean is less than 0, indicating an average decrease in speed. These hypotheses apply to all but one treatment, which is the safe mode treatment. The team also believed that an appropriate alpha value would be 0.1. In the file download t-test, you can see that there is a decrease of 5.69, an average decrease of 5.69, a standard deviation of 4.63, and a sample size of 50. Evaluating this will give you a t-value of negative 8.69, which yields a p-value of 0, which would allow the learning team to reject the null hypothesis, which would show that the file download is significant. In the t-test for playing media, you can see that there's an average increase of 0.12, standard deviation of 4.54, and a sample size of 50. Evaluating this will give you a t-value of 0.187, a p-value of 0.5737, which would allow us to fail to reject the null hypothesis, which shows it's not significant. Next, we can look at the t-test for the ping command. This has an average decrease of 7.95, a standard deviation of 4.92, and a sample size of 50. This would give you a t-value of negative 11.42, which would also give you a p-value of 0. By this, we can reject the null hypothesis, and this is very much significant.
Next followed the virus scan test. As you can see, there was an average decrease of 0.53 megabytes per second, and the standard deviation of the differences was 3.09, and again with sample size 50. The t-value, when evaluated, was to be negative 1.21, which produced a p-value of 0.1155. Slightly higher than the alpha value, this allowed the learning team to fail to reject the null hypothesis, meaning that a virus scan will cause no significant decrease to internet speed. The video rendering treatment followed. Again, the mean difference between the video rendering and the control conditions was 1.26. The standard deviation was 2.66, and the sample size was 50. The evaluation of t gave a numerical value of negative 3.35, which produced a p-value of 0.0008, or 8/10,000ths. This surprised the learning team because it did not match our initial hypothesis, because this p-value would lead a researcher to reject the null hypothesis, which would mean that the video rendering condition has significant evidence of lowering the internet speed. The final test for treatment was safe mode. Safe mode differed from all of the other treatments because the alternative hypothesis instead seeks to show that the mean difference is greater than 0, which means that running in safe mode causes a positive increase to internet speed. The learning team believed this because safe mode runs with fewer active processes, which condition was believed could lead to a faster speed on the internet. As you can see, the mean change was positive 0.91 megabytes per second. The standard deviation was 2.52, and the sample size was 50. T came out to be 2.581, which produced a p-value of 0.0064. This leads researchers to reject the null hypothesis and believe only that safe mode can increase the internet speed, holding true to the learning team's initial hypothesis.
Yes, statistics project is done!
Alright, bro, you didn't tell me what went well and what didn't, though.
And now we go live to Dr. Anu Shah with the Success and Failures Report.
Hello there. Well, in this report, we will discuss what actually went well during our entire experiment and what did not go so well. To begin with, there were a few aspects that did go especially well. For example, we had an excellent sample size. We had a variety of treatments that used a wide variety of computer applications, and the tests and treatments were conducted well. However, there are a few aspects that didn't go so well, and we could have done better in these areas. To begin with, in order to get a good sample size, we had to reassign IP addresses, which was very time-consuming. In addition, we had a large number of treatments, and we could have cut down on these because each treatment took a considerable amount of time. And lastly, the entire experiment was a very tedious process.